Okay. So essentially, sigma field is what? So it's a collection of subsets of sample space, okay, which is closed under countable union and closed under complement set. Essentially, that's what essentially we need. And this set is the major building block in which we are going to do everything. We're not going to go outside this guy. So it's a set of all information that we want. Is it making sense? Good. So it's like the topology. So when you are in topological spaces, so it's like you begin with the topologies and then you see, all these things, and then, then you define things based on topology. So it's like this is major playing field actually. Okay. So why this is okay? Why this makes more sense actually? Just think about it. If you think about it. So what does this property is telling you? That okay, if later on we will call this as a measurable space actually. So if I treat this space and I call it a measurable space, it makes more sense actually. Why think about it? In other words, when I'm saying that omega is an F, it means that everything should be measurable. So this is what the first condition is talking about actually. That okay, if you have a random experiment, so it should give you what do you call something. And I'm not talking at the moment measurable in technical sense actually. So I'm saying that okay, if you have, so like all information must be measurable actually in some sense. And if you are breaking down something into the disjoint pieces, okay, closed under countable union. No, so there isn't any. So if we have some measurable pieces, the countable number of measurable pieces, and you combine them, the resulting thing is still measurable. Okay. And similarly, if happening of something is measurable, then not happening of something should also be measurable. Anyway, so something pretty simple. What's a probability measure? So what's the last thing is P actually. Okay. Let's define the last thing. Okay. Let's define the last thing. What is P? So P is what? So P is a map from where to where?
So omega to R.
Not omega, but from F into R.
0 to 1.
Should be 0 to 1. So it's pretty intuitive that this should be the case.
So it's probability.
Okay, well, F is what? It's collection of events actually.
Yes.
Then the P is a map which takes an event and gives you the chances actually of occurrence. Okay. So P is a kind of a map. So if you operate it onto, if you feed sample space in it, it's going to give you one actually. Second thing that it is going to tell that that if I have say countable sequence of events mutually from F, but they are mutually disjoint actually. So this is what additional condition. Mutually disjoint.
Then probability of union.
Then it must satisfy the countable additivity property. In other words, if they are disjoint pieces of information, and you want to, compute probability of their union, their
Union of
combination,
probabilities.
then it must be same as the sum of the probabilities equal to 1 to infinity. Probability of AI. Okay. So this property is called countable additivity. Okay, I'll more talk about it actually. It's very intuitive. When we will define basically Lebesgue integral, it's a miracle. I can't tell you now, but this is a miracle that, what do you call, Lebesgue thought of. It's not that basically Lebesgue thought of probability measures. He thought of basically, general measures, or maybe the Lebesgue measure actually that he thought of. But this is genius. Okay. How it is genius? Seems simple. The best things are always simple actually. The best solutions are always simple in nature. Okay. If you are getting messy in order to solve a problem, it's good, okay, that you solve a problem, but if it is not simple, wish your solutions to be simple actually. Anyway, okay, so if I have a map from sigma field into the 0, 1 that which satisfies these two properties, you call such map as a probability measure. Then P is called a probability measure. Okay. There are exercises in these books. These exercises are by default exercises for you. The probability for finance. I'm doing the chapter 1 of probability for finance. Okay. So there are exercises for it. So for example, exercise 1.1 and 1.2 is also, what do you call? Okay. Yes. So these exercises are the exercises that you have here are by default exercises for you. So you have to do them actually. So I don't need to tell you to try to bring those solutions and discuss with me. So I hope you understand probability space. So probability space is a triplet. Okay? And for the rest of our time, either we are going to live in probability space or in some kind of measure space actually. Okay? So if you are doing, for example, a probability theory, you are living in a space that is probability space. Okay? So omega is sample space, F is a collection of events, and P is the making sense of or computing the chances of those events actually. That's actually pretty simple. Okay? That's pretty natural. So omega is sample space, F is a collection of events, and P is a way to compute the chances of those events actually.
Sir, these two are axioms for P.
Which one? Yeah, obviously these are examples. So if there is a probability measure, it must satisfy these two probability measures. Okay. Now there are some pretty simple consequences of the definition that we wrote. Let's write those. So the theorem says if you have a probability measure P, okay, so if P is probability measure, then following are the obvious properties of the probability measure. So the probability measure is giving you what? it's giving you, it has this countable additivity property. Okay? But it tells that, okay, so if you compute the probability of countable union of the events, it's same as the sum of the the probabilities of basically the events. Okay? But you can ask a natural question, how about finite actually? Would that be true for the finite? The answer is, if this is true, then it's true also for the finite actually. Okay? So in other words, the probability of union of I equal to 1 to n, AI is equal to I equal to 1 to n, probabilities of AI is actually. Okay, the first property. I'll not write a proof, I'll just give you a hint. Write it yourself. Because if I solve this, I'll solve one of the exercises at the top. Okay. So, hint is this. Can I turn this union into something like this actually? Limit. So, would there be a way to basically
Partial sequence. Partial sequence.
partial sequence? So the hint is this. From A1 to AN, you have these sets. From AN plus 1, so it's like, assume that AK is empty set for K equal to N plus 1, N plus 2, and so on and so forth. Okay? And now I can do what? I can, so I can write this as
Union
of
of
I
1
equal to 1 to infinity. Okay, apply that property and you have the proof. So it's a pretty clever one. Huh? So this is called finite additivity. That was countable additivity, and this is finite additivity. Right. Second thing. Obviously, all these are disjoint. These AIs are disjoint. Okay? So see, the good thing about this result is, it's not talking about the nature of A's actually. Think about it. So here A, so sum of A's can be discrete, sum of A's can be countable, sum of A's can be intervals, no matter what you have actually. So it's like, here the A's can be anything. Think about it. Because if omega is basically, some part of real number or maybe even beyond that, okay, then these A's are what? These A can be discrete and continuous and discreto-continuous, something like that. Whatever you want. Okay? But the result is still true. How about the probability of A complement? Okay?
1 minus
1 minus probability of A. But try to prove it from first principles. Any guess? Think about it. Quick guess. It's not that difficult. Just use the first part.
A complement.
Sir,
The first part.
omega वाला use कर सकते ना?
probability of sir,
A union A complement में लिख सकते हैं.
sir for F sir we know that if A is equals to if A is in F then A complement is equals to sigma minus A. We can use that here right now.
Sir, omega is equal to A union
Probability of A is equal to probability of
Here's an intuitive argument.
Set.
Here's an intuitive. So he's saying that probability of omega minus A could be the probability of omega minus probability of A. But again, the question would be, is this true?
सर ओमेगा
सर,
को
वो सही
लिखे सर
सर,
ओमेगा
ओमेगा
को
को
लिखे
लिखे।
Ah, the good thing is that, right, omega is A union A complement.
And that's
So when apply, you know, a probability measure on both sides, you use first property and, you know, there you go. Okay? Few of these properties. And obviously, as a consequence of this, you also get the probability of empty set to be 0.
yes, क्योंकि वो सिग्मा
ठीक है? So if A is a subset of B, so it's like there are two events from A, and this implies that the probability of A is less than or equal to probability of B, where A comma B are from F. Okay? Is it making sense?
yes.
So this probability measure has a monotonic behavior actually, that's what it does. So this is what is called the monotonicity condition. Okay? And again, think about it. So you might have proved these results when A is a discrete set, or maybe when A is a continuous set or something like that. But here, it's like these are pretty general results actually, so they are true in general. Okay? How you can prove it?
Sir,
The hint is, okay, so let's not tell you. The hint is this picture actually. So keep in view this picture. Okay? So A is here, so this is your A. Keep in view this picture and try to write an argument for it. So think about it.
सर एक और बात, जब हमने P को डिफाइन किया है F से 0 1 तक, तो वो जो पहले हम डिफाइन करते हैं कि probability of an event, I mean कि an element from F, उसको भी हम मीनिंग दे सकते हैं ना यहाँ पर. इसको अप्लाई करें अगर F के किसी एलिमेंट पे, तो that will give the order of that event divided by the order of omega. वो यहाँ पर हम नहीं डिफाइन कर सकते.
That is a particular case actually. So that's one example of it actually. That's just one example. We're going to get into the examples. But that's one example. So that's one kind of measuring the chances actually. But we know that that kind of measuring way is rubbish. It's absolutely rubbish. Okay? Because probability of life on Mars, 50-50. Probability of intelligent life on Mars, 50-50. What the heck? Okay. Anyway, so keep this picture in head and try to write a proof for it. Second thing, you can prove, so like, okay, this is true when this or accountable additivity or finite additivity is true when AIs are disjoint actually. What if the AIs are not disjoint actually? So in other words, if I have the union of finite, and this is important, okay, AI, and it's their probability, then I can estimate them by the sum of the probabilities of AI actually. Where AIs are what? They are elements from. Okay? So what you can do essentially, if you think a hint for this is that like this is a particular case of it, isn't it? Maybe okay. The hint is to try to prove it inductively. Try to prove it inductively. Huh?
Sorry, union probability greater than first.
Minus.
This must be the greater actually. Okay? Think about it. Even so, it's like this intuition gives you. So, what is the probability of A union B?
Minus
Classically,
Probability
is
of
less than or equal to probability of A plus
probability.
probability of B, because you have a minus something here actually. Okay.
सर ये ऐसे होगा कि पहले 1 और फिर सम करेंगे 2 to n फिर
God knows कैसे होगा.
थर्ड
Use induction. Okay, the hint is induction. So first you can prove this result, probability of A1 union A2 is less than or equal to probability of A1 plus probability of A2. So first give your try to them actually, and then generalize it actually. Okay, then generalize it. So you can prove it inductively. So when you are writing proof, kind of the short proof is given in the book actually, but I would suggest that these are good exercises. Try to do them. Try to write these consequences for yourself. There is no need to not consult with the book. I think it will be a good thing actually. Okay. The two things that I'm interested in to do is basically this. So if I have an increasing sequence of events actually, okay? So if I have an increasing sequence of events, so an is contained in an plus 1, and this is true for all n, okay? For all n. Then probability of union of I equal to 1 to infinity ai is going to be equal to what? So it's going to be equal to limit n goes to infinity probability of an. Okay. Okay. So if I have an increasing sequence, so I have something like this actually. So I have, this is my A1, and this is my A2, and this is my A3, and so on and so forth. So what is it saying? That okay, if you keep on unioning these, and then you want to compute the probability of a union of all these, okay, this must be what? Take the, okay, roughly, not the last one, but the biggest one, limiting one, okay, that would be basically what we call the probability, because that limiting one is going to absorb all of the events actually. Okay, how to do it actually? The trick is to do this actually. So I'm not writing a complete proof, just leaving things for you to fill, because this is what learning is actually. Can I see this thing as, think about it, probability measures are very happy when you operate them on disjoint sets actually. Think about it. They are very happy. And you need inequality, so this is what that means. They are very happy when you operate them on something which is disjoint. Question is, can I see this thing as disjoint union of something? Yeah, it's not that difficult. Think about it.
Yes, sir. We can have
Boundaries.
this A1 and then
You know the boundaries.
A1
So it's like
complemented A2.
this part,
A2
this
minus
part.
A1.
Yes.
Okay.
Donuts these.
So I'm saying that okay, take B1 to be A1, then B2 to be
A2 minus
A2 minus A1,
Sorry.
and B3 to be A3 minus A2 actually. Okay?
B.
Or B2 the better.
A2. A2.
Sir, then
नहीं है तो पूरा से जो करना है
otherwise let me
Yes,
Okay,
yes,
okay,
A2.
A2 plus, yeah. And so on and so forth. ठीक है?
Yes, sir.
And I'm saying that if I take the union of all these BI's, what I'm going to have?
Same sets.
I'm going to have the union of
probabilities of BI.
probabilities, but you know, all these AI's actually. There's no difference between this union and that union. Okay?
Yes, sir.
But ये disjoint है.
Okay. But these are not disjoint, these are disjoint. So it's a nice trick. You know? Very clever trick. So I want to compute this, let's compute this.
Yes, sir.
So if you want to compute this, okay, this is left for you to do. Fill the gaps. You know, there's nothing remaining actually if you want to. You know. Okay. After this showing that, let me do it. Probability of union of AI's is equal to
सर हम खुद कर लेंगे.
sum of the probability I equal to 1 to infinity probability of AI's actually. BI's. Okay? But this series is convergent actually. Is this series convergent? Why? Because this is equal to this guy, which makes sense actually. It's a finite number. This exists. Okay? This exists. So this means that the series must be convergent. If it is convergent, I can write it as the limit n goes to infinity as the sum of n equal to 1 to n and probability of BI's actually. Okay, so let's use the same symbol everywhere. Okay, what do you call BI's?
Yes.
And then put the value of BI here, and what you're gonna get? You're gonna get a telescopic sum actually, in which everything will go away except the AN actually. Huh?
Probability of first is
Probability of
No, first one just cancel.
एक
A1 cancel हो जाएगा ये.
sub cancel हो जाएगा. Anyway, so you know, put BI here and think about this sum actually what you're gonna get. ठीक है, so nothing will remain except AI. ठीक है जी? Is it making sense? Good. What is the sixth property? So I'll end on this seventh property and the last property. I'll not go further. Maybe if you wish I can do one example of the things. Okay? Which is the sixth one, okay. The sixth property is this, that I can generalize this, you know, finite subadditivity to the countable subadditivity now. Okay, so the probability of union of I equal to 1 to infinity AI is less than or equal to the probability, the sum of I equal to 1 to infinity probabilities of what we call AI. Okay. So what to do with it? Let me write seventh first. Okay. Which I'm not going to prove. It is just a dual to this statement actually, fifth actually. So here you have increasing sequence. What if you have a decreasing sequence actually? And instead of taking union, you have intersections actually. Sabar karo. Okay? Are you getting the point?
Yes, sir.
So if an plus 1 is contained in an for all n in n, okay, then what? Probability of intersection of I equal to 1 to infinity AI's is equal to the limit n goes to infinity probability of an. Okay, so really the dual of it. Okay, so you have to play the same clever trick. is, shall I give you a hint? Will you think about yourself?
So wait,
Okay.
Sir,
So the key hint is that, okay, remember the Uncle D. Morgan. That's the key hint. Keep in mind the Uncle D. Morgan.
sixth part, sir.
The sixth one. So this is what you call, something to do for you. So I'm just focusing on this one. So let's do the sixth part.